Welcome to the notes for 6.2. Today we're going to look at solving more trig equations, but we're going to look at some different kinds of equations and look at some different methods for solving. We're going to focus on the sine and the cosine, and we're going to look at what values our calculators are going to give us when we're solving our equations. So real quick here, it says, in the past courses, you have used the inverse sine and the inverse cosine on your calculator when solving for missing angles in a triangle. As you have seen, your calculator only gives you one answer. But we know there can be more than one answer when solving trig equations. How do we find these other solutions? So it says when we solve an equation like the square root of x plus 3 is equal to 4, we are always trying to isolate the variable by using inverse operations. We can use the same idea when solving trig equations. So yesterday we started out by solving the sine of x was equal to 1/2 by inspection. So we graphed it and we looked at the graph to help us find our answers. Okay, so we never actually solved it algebraically by isolating the variable. So that works for the, for specific values where we have those common angles on the unit circle, but it doesn't work as easily for everything. So this method wouldn't work actually for the sine of x equals 1/3. So are there solutions to this equation? Right, it says, and how many would we see over the interval from 0 to 2 pi? So let's go ahead here and treat it like we did yesterday. We can start out kind of graphing it by inspection here, and then we'll use our calculator to come up with some values. So we're going to look at, y is equal to the sine of x, and then we'll also look at y is equal to 1/3. Let's graph y equals the sine of x first. We know that we've got our points at 0, pi over 2, 1, pi 0, 3 pi over 2, -1, and 2 pi. So if we were graphing this over that interval from 0 to 2 pi, we would see one period of this function. Now, if we go ahead and graph y equals 1/3, we'll just kind of estimate here. It probably is about right here, right? It's just a horizontal line that's running through here. We can see, right, we can see here that there are going to be two solutions, right, over this interval from 0 to 2 pi. So we have two solutions. So we couldn't take this, though, and draw out our own unit circle and figure out, because 1/3 is not one of those typical values that we see, like when we see 1/2 on our unit circles. So let's get out our calculator, and we're going to graph it and find our solutions. So I'm going to use this. This is like a TI-84. Sorry, I can't do everybody's different calculators today. I got to do what I can here on the iPad. So I'm going to graph my y equals the sine of x, and then I'm going to graph my y equals 1/3. All right, and then I'm going to just double check here, make sure that my window is going to go from 0 to 2 pi. Okay, we got all that in there. I'm not really worried about my y values. It goes from almost -4 to +4, which should be more than enough space for us to see what we need to see on our graph. So let's go and look at our graph. And there are our functions, right? Looks like the ones we just graphed on our paper. And we're just going to find the intersections. So let's start with the one on the left here. So remember, we're just looking at the x values here, right? Whoops, I accidentally moved it there. Our x value would be, we'll round it to 3 decimal places. So be 0.340. Let's go ahead and record that. So this one right here would be 0.340. And then let's go over and look at the one on the other side there. That one looks like it is about 2.802. Remember, these are radians, right? So that's 0.340 radians. And this is 2.802 radians. Okay, so like these are not just our common angles that we're used to dealing with, where we write them in terms of pi. All right, so let's just put our calculator aside here for a second. Let's go on to the next part. It says, now let's solve this equation over that same interval from 0 to 2 pi by isolating the variable. So we've done this in the past. You've done this all the way back in geometries when you probably started doing this, right? If I have the sine of x is equal to 1/3, right? What we do is we try to isolate the x by doing the inverse. So we're going to do the inverse sine on each side, right? So I'm going to say here, I'm going to do my inverse sine on the left side, so it's basically like saying I'm doing the inverse sine of the sine of x, and on the right side I'm doing the inverse sine of 1/3. Okay, on the left side here, right, we know that when we do the inverse sine of the sine, right, it's going to basically cancel those out. We're left with x equals the inverse sine of 1/3. Now we'll just use our calculator to find that value. So, right, remember, when we were just solving it a moment ago, we got two answers over this interval from 0 to 2 pi. But when we type this in on the calculator, we know that we're only going to be able to get one answer. Our calculator is only going to spit out one answer. So let's go here, and let's go to our calculator screen, and we're going to do inverse sine of 1/3. And you see we get that 0.340, right? I'm just rounding it. So our calculator gives us this number, 0.340. Okay, so which one is it giving us, right? If we look back here, right, it gave us the one over here on the left side. Okay, but how would we get this one on the right side here if we didn't have our graph to look at and get? Okay, so we need to think about that, and let's think about the way that we've solved these in the past, right? If we think about our unit circle, and I'm just going to draw the top half of it, right? If we draw just the top half of our unit circle, okay, we know here that one of our angles was 0.340. So if we think about this, right, if this was 0 radians, this is, you know, we could say like pi over 2 is the way we normally read it there, but if you think about it, it's like saying, you know, 3.14 divided by 2, right? If you wanted to think about it in like a decimal form, you could convert it over. You know, we were pi here, but this is really the same thing as approximately 3.14 radians over there. So 0.340 radians is going to be like our reference angle, right? So because it's in the first quadrant, we're going up this way 0.340 radians. Okay, because we're talking about the sine of x was equal to 1/3, remember, if we were looking at the point right here, right, it would have been something, comma, 1/3, right? The y value, the sine is always equal to the y value. The y value would be 1/3. Well, we know that in the second quadrant, our sine is also positive, right? So we've got something over here, comma, 1/3. And we're not really worried about what that cosine value or what the x-coordinate is, right? We're trying to figure out right now what is the angle of rotation, right? As we go from here all the way around to here, right? So we've got this first one that was 0.340. Remember, that's just like our reference angle, so we could actually think about going backwards from here. This is the way we did it in Algebra 2, 0.340. Okay, they just were nice clean angles, or we did them with degrees. So if we go back 0.340 from here using that reference angle, where are we going back from? We're going back from pi, which is like 3.14 radians. So let's use our calculator to figure out what our angle is. So we'd say here, okay, we're going to start at pi, because we're in that second quadrant, and we're going to go backwards 0.340 radians, right? So let's pull that calculator out, and let's do pi minus 0.340. Let's see what we get. Right, 2.8015, which I think we rounded that as 2.802 before. Right, that's 2.802 radians. So wait, what did we see? Oh, that's the same answer we got over here. Okay, because think about it. This is like our first quadrant, and then like our second quadrant, right? That's our second quadrant answer. So, right, two different methods, but we can get the same answers. So what you probably want to start thinking about here, right, like which one seems like it might be the easier one for you as we're working through this, okay? Let's go on to the next problem. It says solve the equation over the interval from 0 to 2 pi using inverses on your calculator. Okay, so before I actually do it, okay, before we actually solve it there, let's just take a moment here and kind of illustrate where these angles should be. Right, so I'm just drawing out my unit circle. You can take a moment there, pause the video if you need to, if you want to sketch out there. Oh, that was way off, wasn't it? It's all right, we can cheat it a little bit here. Let's do, just move that over. That looks better. All right, there's our unit circle. So we've got, right, our x-axis and our y-axis. And when we're talking about the cosine of some given angle is 0.85, right? Remember, this is a positive value. So if the cosine is equal to a positive value, we know that that can happen in quadrant 1, right, because this is positive and positive. And that can happen in quadrant 4 because this is positive and negative. So this is like, if we just kind of randomly choose a spot here, right? If this is our angle, right? We know this angle has an x-coordinate of 0.85, comma something. We're not worried what the y value is. But we know that the second angle that we would have to come up with would also be on the right side, but it would have to be down in quadrant 4. This one also has an x-coordinate of 0.85. So something to think about here, right, is like where could our angles possibly be? So let's go ahead here and solve this one algebraically. So when we do our cosine of x is equal to 0.85, right, and we're trying to isolate the x. We're doing the inverse cosine on both sides. Now you don't have to write it out on both sides like I did on the previous one, because we should know that we're doing the inverse cosine to both sides. That's how we get our x by itself. And what we've got here is the inverse cosine of 0.85. So let's type that in and see what we get on the calculator. So second cosine, 0.85, enter, and we get about 0.5548, so we'll round it to 0.555, okay? So we have x is approximately 0.555 radians. Okay, so that means that this angle that we just found right here, right, is 0.555 radians. Okay, so if that's one of our angles, we still need to figure out what the angle is going to be down here in the fourth quadrant. Now, when you used to do, like, you know, your bow tie angles, and you draw on your bow tie, right, this central angle in here is the same on both sides. So this would be 0.555 going this way, but we're trying to figure out our angle as it goes all the way, it goes all the way around to here. Right, so we just know that this little piece of it, right, is 0.555, okay? So how do we figure out what the rest of it is? Well, remember, since it's a fourth quadrant angle, right, it's a fourth quadrant angle, we're going to take our value here, right, if we're at 0, we're also at 2 pi in the fourth quadrant, and we're going to go backwards our reference angle. So to figure out what what we're at right here, we're going to take 2 pi and we're going to subtract 0.555. And that will tell us what our angle is. So let's take it here. Let's grab that calculator. Let's do 2 pi minus 0.555. Enter. And we get about 5.728. Again, those are radians. So here are the answers that we have. We have 0.555 radians, and we get 5.728 radians. Each of those, if we take, the cosine of those angles, we get 0.85. All right, so let's move on to the next one. Solve the equation over the interval from 0 to 2 pi. And we are using inverses on our calculator. Okay, so we're going to do the exact same thing that we've been doing. Okay, before we do it here, remember, so 0 to 2 pi, just to help clarify here, right, because we're getting these weird decimal angles. But if we were thinking about this, instead of being in like those exact terms of pi, this is like 0 and this is like 6.28 radians. Right, now 6.28 is rounded, but remember, when we do 2 pi, this is just a nice convenient way of writing it, but it really is 6.28 radians. So there are 6.28 radius lengths that fit around a circle. So to find our answers on this next one, we're going to talk about the sine of x is equal to negative radical 3 over 4. Okay, so before we start, let's just take a moment here and think about where could these angles be? So we've got our unit circle. Hopefully yours is better than mine. Yikes. Oh well, I'll live. Okay, so we're gonna go ahead here, right, and we're gonna think about where is our sine negative? So we're looking for the angle, the sine of our angle equals a negative value. So that means we have to be in quadrants 3 or 4, right? Because in quadrant 3 we have negative, negative, and in quadrant 4 we have positive, negative. And what we're focused on there, because the sine is our y value. So let's just go ahead here and draw in. Oops, sorry, let me draw that with markers. There we go. And this circle is really bad. I'm kind of embarrassed, but just go with it. Okay. Oh, doesn't even look close. Let me do that. So that's just a little better. All right, you got a little break, so that's good. All right, so here we go. We're going to take this now, and we're going to think about solving this by using inverses. So this would be saying x should equal the inverse sine of negative square root of 3 over 4. Okay, so if we type that in on the calculator, okay, we have second inverse sine negative square root of 3 divided by 4. We're going to get x is approximately negative 0.448. Okay, so wait a minute. Let's think about that for a second. Our angle is negative, right? Normally when we start here, we start at 0. And if we went up here, this would be like pi over 2. What is half of pi? Let's do that. 3.14 divided by 2, right? So this is normally about 1.57 radians, or pi over 2. This is about 3.14 radians. When we get down to the bottom there, right, if we did 3 pi divided by 2, what is that? About 4.71 radians. And then we get back over here, this is about 6.28 radians. Well, this is a negative. What quadrant would that fall into? So remember, where our positive angles usually go this way, our negative angles kind of go this way, right? So negative 0.448 is a fourth quadrant angle, right? This is in the fourth quadrant. However, it does not fall in this interval from 0 to 6.28, right? So this is not in the interval. Right? It falls outside. But that would be this angle. This angle here is negative 0.448 radians, going back like that. So can we think about a way that we could come up with the positive one? Right, so when you think about our lesson yesterday, we talked about finding all of the solutions. So every time we go around the circle, right, or go around our unit circle, if I was here and I went all the way around my circle until I got back here, I'd be in the same position, wouldn't I? Okay, so we need to go forward a full cycle so that we end up where we need to be. So how far have we gone? Well, we've gone 2 pi radians. So to get our first answer, right, let's take negative 0.448 and let's add 2 pi to it so that we can get an answer that falls within that interval that we're looking for from 0 to 2 pi, all right, or 0 to 6.28 radians. So pull out your calculator and do negative 0.448 plus 2 pi, and you see we get about 5.835 radians, right? And you see that falls in this interval that we've got up here, right? That falls in our interval, right? And you see that it's between 4.71 and 6.28, so it seems like that's right, right? So there's one of our answers. This is the one from the fourth quadrant, right? So that's from our quadrant 4. But now we still need to figure out the one from quadrant 3. Okay, so when you think about this, right, we went back negative 0.448. Well, that means our reference angle is 0.448, right? Our reference angle, the one that we can use in all of our, right, if we drew out our entire bow tie, right, each of these would have that 0.448 angle in there, right? We could even draw it in our second quadrant. Draw it in there. There's our full bow tie. We know that that central angle in each of them is 0.448. So if we're just trying to figure out now our angle that extends from here all the way around to here, we know that we're already at 3.14 radians once we get to that side of the circle. So we can take that, or pi radians, and add to it our reference angle to figure out where we're at when we're down here. So let's go ahead and do that. We're going to take pi, and we're going to add to it 0.448 radians. We'll just pull out our calculator and do that. We're going to get about, if we rounded that, that would be about 3.590 radians. And that is our quadrant 3 angle. Right, if you look there, right, that falls between 3.14 and 4.71, so that means that is in the correct spot. So these would be our two answers here. Right, this one is our 3.590 radians, and the one over on this side here was our 5.835 radians. Now, if we were asked to then solve the same equation by using graphs, okay, and then we could talk about which one's easier. Let's do that real quick, right? So we have the sine of x is equal to negative radical of 3 over 4. Let's go into our graphing here. I already have the sine of x in there. I'm just going to clear this out, and I'm going to do negative second radical 3 divided by 4. And I think my interval was already set up as 0 to 2 pi. It is, so let's look at our graph. Okay, and now if I'm looking at my answers, right, let's just find that intersection point. Bam, there's our 3.590. And here's our other one, 5.835. You see, those are our two answers. So I'll let you be the one to answer the question here, right? Everybody's got a different opinion, but which method did you just feel was easier? Okay, I know some of us are kind of reluctant to use the calculators there, but man, they sure make it easier if we can graph it and do it that way. Okay, so in my opinion, graphing was much more efficient. All right, let's jump in here. We got one more to do. Solve the equation over 0 to 2 pi by using inverses or graphs on your calculator. Okay, so first one we have -4 times the cosine of x equals 3. Remember our goal to isolate that trig word. Let's just go ahead here and divide each side by 4 first. So if I do this here, I have the cosine of x is equal to -3/4. Okay, so if I want to do this one using inverses, I'm going to take it and, right, just think about where's this got to be. Where are the cosine values negative? Well, that's got to be in quadrant number 2 or quadrant number 3. So let's just draw on those parts of the bow tie. All right, let's take that, let's draw that in here, right? Those are, figure out what the corresponding angles are over here. Okay, and let's do our inverse. So we're going to say our x is going to equal the inverse cosine of -3/4. Okay, and let's see what we get there. Let's pull the calculator out. Get about 2.4188, so 2.419, we'll say. Radians. Now, when you think about that, right, 2.419 radians, if this was about 1. I think we said 57 radians, and this is 3.14 radians, when we do the inverse cosine right here of that -3/4 there, it actually gave us the angle that we were looking for, 2.419 radians. Okay, now we will figure out why is that happening here in a future lesson here. But if we wanted to find the second one now, right, we would just need to figure out, well, what is our reference angle? What is the angle that's left in between here, right? Because from here to here was 2.419. So if I want to figure out the rest of it, I want to take my pi radians. Let's do pi radians minus 2.419 to figure out what that missing piece is, or our reference angle. So second pi minus 2.419. We get about 0.723. That's our missing piece here, right? That's our reference angle. So we're going to take it then, and we can go ahead there and say we're going to take pi now, and we're going to go past it that same amount. So we're going to do pi plus 0.723. And you'll see we get about 3.864, 865 there. So that would be our angle that is down here. This would be 3.865 radians right here. Okay, so that is how we do it with the inverses, right? But it says we could do it with either one. So let's just go ahead and do with the calculator real quick. So I think most of you probably like this better now. Let's see what happens. So let's go in here. Let's clear it. We're going to say, I'm going to just graph it in this form here. I'm going to do my cosine of x. And then we're going to do a negative 3/4. We're going to graph it. We're going to look for our values there. So we got about, what, 2.419, right? And then we got our second answer, 3.864, and then we had a little bit of a rounding issue there because I rounded my other values, so it kind of just tweaked our answer just a little bit. But you see, you get the same thing. Okay, so the question now, which do you prefer when solving trig equations? Do you prefer graphing or do you prefer inverses? Some of you might like this better. Some of you might like pulling it out and using the calculator. That's up to you. All right, last little tidbit here. Notation for inverse trig, this one here, just pay attention for just a moment longer. It says there are two standard notations to represent the inverse for trig functions. The first uses inverse notation. For example, this is what you were seeing in this lesson. This is what you're probably used to. Okay, it says you must be careful with this notation because when you write it here, the inverse sign is not the same as y equals 1 over the sine of x, right? Which, when we see that there, right, that's like a reciprocal. Okay, so we don't want to mix up our inverse sign with like our cosecant, because our cosecant is the actual reciprocal of the sine function. Okay, so there is another form that sometimes helps out with that. So the other form is what you see here, y equals arcsine of x for the inverse of sine. So this is just another way of writing. This is another way of writing this. Okay, so when you're trying to do the inverse of sine there, right, you can also use arcsine or you can use arc cosine. Okay, so it says this notation, y equals arcsine of x, can be thought of as the arc whose sine is, okay, and this connects the inverse back to the unit circle. Okay, doesn't really matter which way it's done here, but you may see both of them in future math classes here if you're continuing on into higher level math. Okay, so you might see this one or this one. Just know that they mean the exact same thing. Okay, so these are the same thing. All right, that's it. I know that that was a lot of fun for you, and hopefully you learned a little something. If you have questions, please make sure that you reach out when I get back to class. Thanks for watching.